Okay, we're back. And, alright, so anyone who was watching the earlier video or anyone who was here who downloaded the virus that I sent you to, I'm so sorry. I didn't mean to lead you to a virus. However, that's the world we live in. And that's what happens when you go to websites these days. But anyway, apparently this one's working. It's cyberduck.io. Cyberduck.io. I'm doing this for the benefit of people listening to the recording and not sitting here right now. So cyberduck.io. You select, do you want the Windows version, you want the Mac version, then you get the real program, not the virus. And I do apologize if you downloaded a virus earlier. You'll have to clean your system. When you get the duck, when you download it, you should get a duck. You should have a duck. Whether on a PC or a Mac, you get a duck. Yellow, cute little duck. Open the duck. When you open the duck, if you don't get anything, you'll have to press on Open Connections. For this class, you want to use, on the top, you want to go here, SFTP. Secure File Transfer Protocol is what that stands for, because we're in a secure shell, in a secure environment. You put the URL in here. What's the URL? It's the IP address. 53, here, actually I can tell you. For our class, it's 2325373.22. No, that's the wrong class. It's this one up here. Here, I can edit this one, actually. There we go. And then you'll have to put your name in, and then you'll have to give it a, you know, I just thought of something terrible. Guys, I'll change your passwords. You know why? If this is being recorded and people on YouTube and stuff are watching this, I'm giving the IP address out, I'm giving all these student accounts out, and if you don't change your password, someone can log in as you, actually. There's nothing to stop them from logging in as you. Actually, maybe they'll do your homework for you. Alright, you guys out there, could you do the homework for this class? It's called group share, crowdsourcing. Alright, so long story short, put your name in there and your new password after you've changed your password. You got to make sure you change those passwords. Don't select add to the keychain, but don't select anonymous login. You need to provide a password. So then when you press on connect, you put a password in, and then save the bookmark. So you go up to bookmark here and click on bookmark, and you save the bookmark, and then you can come back to it. History's cool. The bookmarks are what's showing here, so you'll have to bookmark it. So if you have problems bookmarking it, here, want me to come over right now, or did you figure out how to bookmark it?
A prompt to click on allow or deny.
Allow. Let me go over and take a look. Alright, so for those people who are trying to find how to bookmark it, there's a little button down here that will add it. So, add it to your bookmark. If you downloaded SSH client, you already have an FTP client. You don't have to worry about this duck at all. You only need the duck if you're using Mac. Really. That's the only reason why you need the duck. If you're a Windows user and you're using SSH shell, you don't need the duck. The duck's extra. Skip the duck. I'm going to put my duck away because I don't need my duck right now. And I'm going to go back to my shell that I had opened. And I'm still there. Am I still connected? No, it looks like I have a broken pipe. My pipe probably broke when I was away for the computer too long, and it suspended, or I went into resume mode, or, you know, computer rested while we were on break a few minutes ago. So actually the pipe is an interesting concept. The pipe symbol looks like this on a computer system. We're going to see that pipe actually pretty soon. And the pipe is actually a connection. So it means like you're sending from one point A to point B via the pipe. So the pipe into that terminal, excuse me, into that Unix server that I was connected to, it's actually called a pipe. It's also called a connection for humans. We call it a connection. The Unix system is going to call it a pipe. The pipe gets broken when the connection gets lost. So it means, you should have just said lost connection. But I wasn't really connecting. I was connecting. I was piping. So anyway, I'm going to use my arrow keys and come back and log back in. And see if my password still works. And it does, which is excellent. All right, so now I had some questions over the break, and I thought maybe I'd answer them while I was recording. First question is, you shell, well, here's actually, I'll get to yours in a second, but the first one was you go like this, and one of the interesting things was we noticed that your shells are not bash. Your shells were shell, SH. So when you actually looked at your shell, you don't get a bash shell. Because you don't have a bash shell, you don't have the colors. You want the colors, type in bash. You get the colors, and then you get the history that works as well. So then you notice that we have different features for different shells. Why they did not give you bash by default on your accounts, I don't know. But it was an interesting learning experiment. So now, if I've typed in BASH and I'm in a shell, I'm in a subshell, a child process of my main process, which means I can't go back until I close my shell. Why would I ever want to do this? If I had something running in the background of my main shell, and I wanted to start something brand new, and I wanted to reset my environment variables and have a brand new shell for clarity's sakes, then I can open up a subshell, go into the subshell, do some stuff, and eventually go back. It's meant to go forward and back in a sequential kind of process, but not skip around. So in order for me to go back, I have to type in exit. And if I exit, then I go back. Now I'm back in my other shell. And maybe PS is probably a better way of seeing what shell you're in. If you want to open up multiple sessions, and then you're going to say, well, what's a session? This is a session. They used to call it a telnet session. It's a connection. I can actually have multiple connections. If I have multiple connections, I now have a split personality. This is what you want to do if you're going to multitask. You're going to open up another window. In another window, I'm going to log in. I wonder if it'll let me log in. Permission denied. Let's see. Oh, wait a minute, that's student 22. That's what my problem is. In fact, that was probably my problem before, actually. I want to be root. Hold on one second. You know what? That was probably the problem why my password wasn't working. Who knows? Ah, there we go. What I do in here, let's just do this. It's all on the same drive. I have two logins. So what I do in this window will be reflected in the other window. So if I'm in here, and I see the same stuff that I see in here, and in here, I say, well, actually this is a good test. I'm gonna nano, actually, I'm just gonna I'm gonna copy. I'm gonna cp index.html to let's see if this works. And I see let's see if this works in here. I'm going to come over here, I'm going to ls, and look at that. Let's see if this works. So I actually I'm in the same session, but I'm in two separate sessions, but I'm connected to the same account. I'm in two separate shells. So if I type in something over here, I put ls in the background as an example, and I type in ps. If I type in ps over here, I don't have that process running, because that process is running over here. So if you want, you can create multiple sessions. Creating multiple sessions, you have multiple windows. These are not sub-nested. These are one session here, one shell, one shell. They're not one shell inside of a shell. They're shells simultaneously running in parallel. If you really want to get work done, you load up multiple shells, all at the same level of the hierarchy, all at the top, all parent shells. Then if you want a sub-shell, you type in the shell name, you load up another shell inside of the parent shell mixed with a child shell. Then you got a brand new environment. You're only going to do that if you want a brand new environment to kind of sort things out, make things cleaner for yourself. Because you can add stuff to the environment variables, you can change environment variables around. In the old days you did that because you were in fact you guys will probably do it for a good reason. You're in shell, but you want to go to bash because you want the colors and you want the history. Then you're going to subshell. From your main shell, you're going to go to another shell, and you're going to be in bash, because you want the bash features. So if I was in bash, and I say, well, I want a C shell, we don't actually have it on here, because I already typed it, and it doesn't work. C shell is a shell, not installed. But it allows you to type C commands. It allows you to type, printf, scanf, regular C programming language, write C programs, run C programs without compiling them. So it allows you to write scripts and things in C a little easier than having to actually pull up an editor and do it. You just open up the C shell. I'm in Bash, I open up my C shell. I can open up Perl, Python, PHP, all the same way. In fact, I don't know if Perl is supported. Perl is supported, so I can go into Perl and I can run a Perl script. It's a shell. Perl's a shell. Python, let's see, I'm going to Control-C out of this for a second here. Python is another shell. See how this shell here, I can go in Python, print, hello there. And I got hello there. And now I have a command line interface where I'm talking to a Python interpreter. And the Python shell is inside of my Bash shell right now. Now I'm going to go into the C shells, she sells, she shells. And I'm going to learn. I'm already starting to do it. My pronunciation of the word shell is a little bit funky. But anyway, long story short, I can't go inside of Python and load up Bash. It's not going to work. But you can actually see here, it says Python 7.3. And it's a dialect of GCC, which is actually kind of weird because why isn't GCC working? How do I get out of here? Let's just do this. I'll get out of there. So, GCC cannot be found because it did not install the package. The packages aren't installed, which is the most ironic thing in the world. But I didn't tell the guys I wanted to do C programming. So, but in essence, GCC is a shell-like. It takes your input files. It's a program. It's a compiler, but it's running with the same concept. So you can think about it. You can load up a text file to load the shell inside of the text file. Inside of that shell, do some stuff, and then exit the shell. That can be done very easily. We're going to do that in the first assignment. Actually, we'll show you a little variation of that. So, yes.
How to come out of Python?
Yeah, I don't know how to get.
Control-C is
Control-D.
Control-D.
D, yeah. Control-D gets you out of Python. Well, I don't know, does it? Let's see. I just exited out. Control-D. There we go. That's out of Python. You can type in help and find out, probably.
Yeah.
I'm sorry?
Even if you type exit also, it's showing type Control-D.
Yeah, if I type in exit. Yeah, I messed it up to the point where I had two windows up, so I just shut the other one anyway, so it doesn't really matter. But Python's a nice little language if you're not, it's a Unix language, yeah, obviously. So, runs in its own shell, so you can just bring up a Python, and they call it an interpreter. So there's a little bit of leeway between in the use of the word shell. A shell could be an interpreter, it can be a programming language. So it has various different definitions. So I wanted to make sure we covered everything that was in that lecture, and I closed the lecture somehow, so let me open that back up real quick here. And we were sort of down next to the bottom here, and I want to say we got very far. There were a couple of follow-up things I wanted to make sure we hit. We were talking about I/O, I believe. Here we go. So we have standard input, standard output, and standard error. So this is the standard input is the input from the keyboard. The output is what we're calling the screen. It's really our foreground shell is where our output's coming into. And then we have standard error, which we don't ever see unless we ask for it. We can cat standard error. We can see what's there. We can actually use these keywords. Send a program output to standard error. Send it to standard output. Why do you want to do that? We're going to create a script. We're going to run the script in the background. And we don't want this stuff to go to the foreground. Because standard output is the screen. What if we don't want this stuff to go on the screen? Because we're running this script and it's on the screen, but then we have another program up, and the screen's going to get it's going to be populated with all this output that's coming from this program. Maybe we don't want that. So we can redirect the output to a file. We can redirect it to another device, another screen, or we can simply save it or discard it. Don't do anything with it at all. So we have ideas in terms of being able to redirect, and it's called file redirection or output redirection. I'm going to call it that. So this little arrow here, and let's just demonstrate this real quick so you can sort of see what this looks like. So far we don't have that many commands, but we do know ls, right? So if I type in ls, I see I have all this stuff now. If I type in ls and I put this in here, this little arrow, this is a redirection operator. In C++, you go C out. You got them going this. C out. You type in C out. You got it going this way. So this is just saying ls. The arrow's going this way, which means it's going into the small direction it's going into. And let's just give it a file name. I'm going to put here my output. Better yet, I'm going to do the -L because I want all the details that go along with this. And I press return, and I go, oh, well, nothing happened. Because normally when I go ls -L, I get it all here. I just redirected that output. So where did I redirect it to? Actually, you see it's right here. It's called my output. So if I cat my output, look at that. There's my output. So that's called redirection. It's called IO redirection. We can also do file redirection. We can take one file and send it to another file. So redirecting takes it from standard input or output to file to another location. Directs the traffic. Piping combines things together. We'll see piping where we take the output of this program and we use it as an input into this program. And then we use this output as input into that program. And then we take that output and we send it to a file or something. So we've combined I/O with piping. What does that do? It allows us to string a bunch of commands together to write these really nice scripts that do a lot of stuff for us. Because who wants to sit at the computer and type in all these commands all day? Instead, going back to Big Bang Theory, if you're Sheldon, you're going to write the script. You're going to run it. It's going to take down all the servers in the university, or it's going to do something, you know, by doing something recursively over and over again for days. But are you going to sit there and do it? Nah, it's going to do it for you. You're just going to come back and look at it occasionally, maybe if you're lucky. Or, you know, I don't know. Find someone to blame it on, if that's going to be the problem. Okay, so we have the single arrow. Sends it, redirects it to an output. And here we just did it with my file, or actually my output file. If we use two arrows together, we're going to concatenate. So it appends. So concatenation is actually kind of an interesting thing. It's just append. So when we cat, it's kind of, we can cat two files together. I've been catting single file. I cat single file, I append to the output. So I'm taking and I'm sending to the output of the file, instead of sending it to another file. So I concatenate two files together using cat. I can concatenate using the arrows with two arrows, which means add it to the other one. So similar, you can append the output file instead of rewriting it with the double arrows. So here we have my file. So let's just do it again. So the file is called my output. So now I'm going to do it, what am I going to do? Let's just run the regular ls. I'm going to go ls, and I'm going to concatenate it out to my output. And then now when I run ls, I'm going to see I've got, well, actually it didn't work, did it? Did it work?
Put it in the file, so if you do cat my output.
Oh, yeah, that's true. I'm doing an ls. Yeah.
Yep.
Hello, it's late in the day. So let me actually output the file that I concatenated. So output. Thank you. Then we have, because I just ran a directory listing, I'm like, yeah, that's my directory. Okay. So if I cat the file, then I've got my original one, and then I've got, this is the one I did with the ls, -L command. This is the one I did without the -L command. It just gave me the directory listing. So I can see I have two sets of output all in the same file. A lot of log files are done this way. All you got to do, you want to concatenate instead of overriding it, just put two of them in there, which is actually kind of cool. So in C++, you go cout, cin. Those double arrows concatenates the output, concatenates the input. That's what it means, actually. So that's where it's coming from. It's a redirection It's a redirection operator. And then you can overload the operator to have it do other things. But anyway, that's C++, and we're in Unix. So this is a file redirection, if you're looking for the terminology. Here's our cat. So input redirection is our cat. So input can also be given to a command from a file instead of typing it in from the screen. Cat program 1 to program 2 to command 1. So cat program input. So you're sending input into a command. So I believe we have I don't know if we have an example here. This command series starts the command cat, which prints a file to the screen, program input, which is printed to standard output, which is what we've been doing, which is then redirected to a command, my command. So you can combine the two of them together in this statement here. What can we run? Nano. So let's do cat. Let me find a text file here. Barbara Hecker. There we go. We can go cat Barbara Hecker and then send it to Nano, which is a program file. Nano, remember Nano, text editor. And we have it sent to Nano. Where's Nano? Well, good question. Nano's a GUI program. We didn't run the GUI program. We just redirected the output to it. So you're going to send output to a script. Otherwise, you're not going to run the program. So then we go, PS. Nano's not running. No, it's not. We sent it to a file, but we didn't send it to, we sent it to an executable file, but we didn't load the executable file. So we have to wait a little bit further in the course because we have to get some more commands that we can run. Nano's like the only program I've shown you so far. So let's wait with this a little bit. We'll see it working, and I also have some more cat stuff to show you later on as well. But just know that you can concatenate the output, redirect it to command input with my command. So I guess we could do cat. I don't know. I'm trying to think of something that would make sense right now for the list of commands we know. My output. Let's see. No, not going to work that way. But I got Nano here. Actually, we redirected the output to Nano. It's almost like taking, in that particular command, we actually gave it we gave it the name Nano. If we cat Nano, we're going to see the file content of Barbara Hecker because we copied it to a file called Nano. We didn't run it. We didn't pipe it. We concatenated it. So we concatenated it into a file. So I'm going to remove Nano because I don't like to use the name of something that is a execute. I got ls in here too, so let me remove ls now too. So, long story short, we need to wait for a few more commands before we can actually do something functional with that, and we're gonna see it. So here's redirecting standard error. Now we have to make an error, so we perform a normal redirection. We'll not redirect to standard error. So in Bash, we can accomplish this with 2 and an arrow to get it to go, because standard input is 0, standard output is 1, standard error is 2. So we have a numbering system 0, 1, 2, because people don't like standard input, standard output, standard error. Or instead of using 0, 1, 2, you can use the capital STDIN, STD out, and STD error if you wanted to as symbols, symbolic symbols. So we can go command 2 to file 1 takes the error and sends it to file 1. So let's see if I can get this to work actually. I'm gonna clear it here. Put my inputs. Clear. There we go. Let's see. ls minus something that's gonna. I'm trying to make an error here. Let me see if I can do this. YZ. Oh, that's pretty errorish to me. Bad stuff. Okay, so let's see what's inside of bad stuff. Oops, let me spell bad stuff correctly. There we go. I got the standard error in there. So what I did is I redirected standard error by going 2. So we have 0, you leave 0 out. And then, oh, wait a minute, hold on one second. Hold on one second. I think I gave you the numberings backwards. Input, output. Input, out, yeah. 0, you leave out. Input, output, error. 0, 1, 2. So, no, I thought I had switched these around for a second. And then I had to refresh my memory on the order. Because I put it in the slide the same order that it's supposed to be in. So I could remember the order. Who sits around memorizing orders of stuff? 2 is error. We know that. 0 and 1. 0 we leave out, 1 we put in for redirecting to terminals. Well, let's not do that right now. Here what we did is we used 2. So the command I put in to make the error, I ran ls with a bad switch. So it doesn't really matter. I just have to put something illegal in here. What gave me the error message, it didn't put it on the screen. Instead, it redirected it, and it redirected to, here, I'll put here bad stuff too, which is really going to be the same error. So I put this in a script, and all I have to do is this at the end of the line after the command. So I don't want the user to see the error message. It's not going to direct it to standard output. It takes it to error. So this redirects to standard error. Standard error is being redirected to a file. Standard error happens automatically, but we see normally standard error. If I take this out, as an example, I see the error to the screen. If I redirect it to a file, then I see the error in a file. Later on, the next day, I can come in, I'm the system administrator, I can come in and I can say, well, what happened last night? Let's take a look at the bad stuff. And I go, oh, invalid option Z. Wait a minute, that command failed. You can also write stuff to yourself. This happened, and it happened at this time, or this date. So we have time, we have date, we have calendar. We have all this internal commands that we can say, well, what's the calendar? What's today? Looks like today's 19th. Oh, our server is not in California. Our server is probably on the East Coast. It's, no, it's 4, 5, 6, 7, 8. No, I don't know where our server is, but it's got the wrong time on it. It's got the wrong date. It thinks it's tomorrow. We got the 19th on here. So I seriously doubt we're going to have the privilege to change the time on this thing. But we could put little cookies in there for us. We could say, you know, go and put this to standard output. Put the date in there. So at this date, this time, we got this error message. And here's the error that occurred. So we don't have to be on the screen, because what ends up happening in the middle of the night is I'll fly on the screen. Next morning, you come in, and your screen looks like this. And you're like, oh, what happened? And you can't tell. So then you go and you look at the log files. The log files tell you everything. Okay, here's our pipes. So using a pipe operator, and that's this guy here, up and down line I showed you. So you take and you put different commands together. So you send this output to this input to that output. So it links the standard output from one command to the standard input to another. Very useful for searching files. And then you go, well, how do we search files? Well, we've got where is, we got find, we got a bunch of stuff that's built in. Grep. We have an assignment that we're going to work with that works with all of this stuff as well. Large majority of activity, find utility is useful. Here's some examples down here. Find this file. Find that file. Find this file and then grep it to another file. I don't know if I'm going to be able to do this one here. Oops, I can move it. I was going to try and cut and paste it instead of having to type it because this is kind of small. See if I can make it bigger. No, it's not going to help me. I'll save on this one because we have an assignment. We have an exercise coming up that will do this. But if you can see this little screen down here on the bottom, we've got a pipe in here where we're going to pipe out and then we're going to grep. And the grep here is searches for patterns inside. So we can find things, search patterns. What does this do? It gives us search and find capabilities. It's kind of like using a search engine and typing something in and getting results back from the internet. But instead we're getting it back from our Unix server. We want to find the file, all these files that were created by bhacker, and go find it. And then apply this pattern to it. And then maybe even separate out the file and do something with it. Then we have packaging files. Excuse me, take a bunch of files and put them together. And this is like Windows people with pkzip or zip. So tar creates and extracts a file. Tar stands for tape archive. We don't have tapes anymore, and some people don't even know what those are. We used to have tapes, reels of tapes that we did backups with. We actually have backup commands still on Unix where you can just type in backup and specify which directory, and then recursively back up the whole directory, like from root all the way down, and copy it to a tar file, and we have tar backups. So utilities that Unix people do to make sure that you've got safe files. And then we have gzip, gunzip, bzip, bunzip. We got so many zips. We got so many. I'm not going to go through them all right now. We have an exercise that will do that for you. So we can worry about that. tar on all the command switches. Tar is a nice Unix command, actually. Different than zip, actually. We know how to SSH. This is a secure shell versus a restricted shell. Our secure shell gives us full access, but it's encrypted. So it's an encrypted remote login that is secure to trust across non-secure networks, aka the internet. Which is why when you connected, you probably got this little message that said, would you accept this certificate or this authentication, or can I add this to the keychain? Usually there's some sort of a security protocol that has to be accepted, because you're going to authenticate and you're going to send some information from your computer to the server and back and forth to make sure you're still the same connection. So it's a managed connection, and the traffic is encrypted. Does it really need to be encrypted for us right now? Probably not. All the stuff I'm doing today, I really don't care about who's watching me. In fact, I'm recording this and sticking it on YouTube, so I really don't care. But if I did care, if I was a company and I was doing accounting and stuff, that might be a problem. So copying files to remote hosts. We saw how to download something with wget. We can actually receive stuff. We can also copy file from one file, left file, to a right file to remote systems using rsys. I don't have another system to copy something to, but I could copy between systems, which is easy to do actually, and you would be copying from your system to another system. Most people prefer FTP to doing that, so that's why the Cyberduck program came into place, because it was, you know, it's a secure, Cyberduck supports secure file transfer versus some of the other file transfer programs out there. So, all right, let's see if there's anything else. We have actually done this one already. You can view all system variables with an env. I wonder if env actually works. Env does work. So does print env. But env is also another way of doing it. So env will give you all the environment variables. Depending upon the shell, you might be able to look at the files .profile for bash and .cshr for C shell. You guys, I think, are on C shell. Let's just see something real quick here, actually. Let's see if I can do this, actually. What was I going to say this one is? .profile. I don't think I'm going to have access to it. Oh, I do have access to it. .files are hidden, which means I can't see them unless I do a, well, let's see if I can do it. An ls, was it -h? No, so there's a switch for it. Which is the one for hidden files? I'm asking you guys. Minus A?
Yes, -A.
A for everything, for all. Here we go. So if I do a -A on my ls and I'm in my root directory, if you go back to your root directory, which is going to be your home directory, I have, that's my shell script. That's my, going back to my environment, that's where I'm defining all my environment variables. So if I edited that file, I can change a few things about my name or about my scripting. In fact, if I go back into Nano, which is what I did before on Profile, but I also have a couple of other, so Profile is going to have all of my startup commands. So let's see what's in here actually. It's loading bash. So if you wanted to load, you could probably change your profile. If you do that, don't worry about it. We could probably just give you another account if you mess it up. The problem is when you start messing with the scripts, if you accidentally type the wrong one in, you don't get a shell. It just doesn't boot. But I can go in and change it for you because I have access to your accounts. So if yours doesn't, actually be curious, somebody load up their .profile. You can't see the file. It's going to be in your root directory. Do you have it? Are you able to see it? Let me take a look at it real quick. I'm actually kind of curious what it's set to. So don't change the script because they have you routed. But what we'll be doing, not today, probably in the second weekend of this course, is looking at these scripts and playing around with the scripts. I don't want to, it's too much to do for the first day to change these scripts. But we have a couple of them that run. We have the .bhsh, which is going to set some stuff, our profile script. When we log in, this stuff automatically happens for us. So it'll set the shell for us. It'll set some environment variables. It'll map our directory structure. It does a lot of stuff for us. And they're sometimes called login scripts or environment scripts, depending upon what perspective you're looking at. So to create a script, and we put some commands and we put it into a file and we save the file. We can also run a shell inside of our script. So we can specify what shell we want to run the script inside of. So let's say we're logged in and we're in a C shell, or we're in a shell, basic shell. Or Born, actually, is the other one. And we want to run it in bash. We can put this at the front, the top of our script file, which is our text file. And we can switch the shell. So it loads up a bash shell, and then inside of the bash shell it runs these commands that we have. Just like when if you've ever written a Perl script, you put hashtag or hash tape sign, and there's a little header you put at the top of the file. It says Perl on it, or Python, or something in there that says what interpreter to use. So the shell picks it up, loads the interpreter that is intended for that particular file, and then loads and runs the commands using that interpreter. So this is a lot of the programming aspect of the environment in terms of specifying something out. That hash sign says that it's followed by a comment and not an executable code. So it's a comment that says use this, and it's inside a bin. Use this shell in running this particular script. We can actually create variables and add them to our environment, and then use our environment variables in storing information. So just when you thought you weren't programming, then you realize this is really a programming course. No, it's not really a programming course, but it is sort of a programming course because you can echo out. We did this a couple of times already. Echoing out home gives us our home directory. Echoing out shell gives us our shell. Here are some examples: home, old password, path, locations, and our executable file. These are all variables that are stored. They're all in uppercase. So setting system variables differs from shell to shell. Bash uses export. So we say export space, this is equal to this, or I'll show you the syntax when we start setting it. C shell, CS uses set environment. So later on in the course, it will actually matter which shell you're in, because the script, the shell commands are a little bit different depending upon which shell you're in. So here's an example. My variable is equal to 10, sets my variable to 10, echo my variable, prints out my variable. So actually, I don't think this is going to work in this. My variable equals 10. Let's see. Yeah, it does. And then echo my moy variable. Well, if I go echo with a $sign next to it, it says give me the value of moyer, which was supposed to be my variable, but I misspelled it. So this actually works in Bash. I didn't think it was going to actually, because you can do a set environment. So you go set env, which is not. Oh, it is no command. It's not supported. So we'll have to figure out which one is going to be used. But just simply, this is the name of the variable. And so we get the name of the variable and we echo the name of the variable, and then a $sign gives us the value, which is pretty universal. Treats it like a variable. This treats it like a value. So we switch it around. We say, give us the value that's associated with my variable, and we get 10. But now later on, if I switch shells, I go here, bash. Right? Now I'm in another shell, and I do that same command. Whoops. So that's the interesting thing. The history is for the different shell that I was in last. It's not for this shell. The history gets accumulated for the shell. So if I want to clear out my history, I want to clear out my environment variables completely. If I typed in, I have to retype it in actually. Echo the meaning of my variable here, it's nothing. Not defined in this environment. So a lot of people will create a shell, set it all up, change environment variables, then load another shell just to do something, and then go back to the original shell. Because you don't want to mess with it once you have it all ready to go. So you could just leave it up, and then just, you want to run something new, just do this here. You know, I got bash going on here. And then I'm brand new. I'm in a subshell. So let's just do what I want to do and navigate around, and then when we're done, we'll just exit out. Well, you could do this for your scripts too. You're in one shell, but you have a script that you really want to run in bash, but you're not in bash. Or you want to run it in Perl or Python. And you load up, and you say, okay, this is a Python file. And you tell it how to run it. When you run the file, then it picks the interpreter and runs it in the shell that you wanted to do. So, all right. So those are the variables, and then the last thing was conditionals. We can do an if, then, else. We'll do that with a script that we'll write later on. And then we can also do loops, do while loops, or do for loops, do loops. Anything you do in C, you can do in the shell environment. So, putting it all together, here's a script. Actually, I'm wondering, no, I'm not going to cut and paste this one. Instead, we'll just start in with the first assignment. So, I don't believe there was anything else in here. Let's skip that one. We'll get to that later. So last but not least, let's go ahead and start in with some good stuff. So let's do the first assignment. So we're going to start it today, and then we'll finish it tomorrow, and then you'll upload it to the EMS, and you'll be done with one assignment. So we'll have this done. Is that the door person, or is that the attendance person?
Yeah.
Oh, that's okay. This is a good time then. Let's pause for a second here. Let's start the first assignment. We won't finish it today, but we'll finish it tomorrow. But it'll give you something to work on if you're bored tonight. Not that you really want to do Unix all night after you've done it all day. But hey, you have to admit, though, it wasn't too bad of a day. It went pretty fast. It's nice when you're doing stuff. When you're sitting there listening to someone talk all day, that's boring. Go into the Unix operating system. You're going to see I put in here the lectures from this morning. You're going to see links right over here. It's going to say Spring 2014. These are the assignments we're working on. So go ahead and get number 1. Oh, number 1 doesn't look right. Let me see if this is the right one. Let's see if it's right. It is right. Okay. So let me show you how these assignments work. There's 7 of them. We're going to do most of them in class, so you don't have to worry about it. But we can do them together. So you want to keep that file that's in your directory, in your student directory. You've got one file in there, it's got your name on it, and it's got your student ID in there. What you're going to do for the next one, it doesn't really matter. You can have extra. I have tons of extra stuff in here. I can leave it alone. I don't care. I'm only looking for certain things. So number 1, we can't do this together. You have to do this on your own. So when you turn this in, because you will have to turn something into the EMS, you will open up this file, and I believe only question number 1 is the only thing that's going to require an answer. Number 1 is, and we're not doing it right now, you're going to do this part at home. I'm going to say a shell is both a command line interpreter and a programming language. I tried to introduce the concept of a shell to you today. So you're going to explain the differences between the following shells. Bash, C shell, Corn, Perl. How are you going to do that? You're going to need to do a little research. It's a graduate course. It requires you to do a little research. You don't have to explain all of the different features. If you gave me all the different features on this, you'd be writing like 400 pages of stuff. This is like 4. Perl is a programming language, by the way, but it's also a shell. I could have put on Python up here too, but I didn't. I just put Perl in here because that's really one of the more traditional Unix languages or shells, but it is a shell. So you're going to go home and you're going to take a look and you're going to research it. Only give me a couple paragraphs and give me the comparison. So find out a good understanding of what bash is. Once you know what bash is, write a little paragraph and say, bash gives you this, this, and this. It was the original shell, blah, blah, blah. Bash is what we get on MacBooks, by the way. It's really nice. It's very current. And then talk about C shell and corn shell and Perl and all of the other ones that I'm giving you here. There's only 4 of them. So give me a couple paragraphs, 1 paragraph each. Just 1, 2, 3, 4 paragraphs. Less than a page. Do not write more than a page on this. Write it in your own words. Don't cut and paste from the internet. That's how you're going to get an A on this, is you're going to put it in your own words. And you're just going to give me the comparison. Now let's start something. In your home directory, so number 1, you're going to answer this one. If there's anything else, I'll tell you as I go through the assignment with you. I'm going to go through the whole assignment with you in this class. You may not necessarily do the same thing for all of the assignments. We'll just see. Okay, so number 1, in your home directory. Well, that's the directory you put that file in that has your name on it. We're going to make it a subdirectory, and we're going to call it bin. If it doesn't exist, probably doesn't exist. Actually, somebody put it in there, right? Someone's already done this assignment. So this assignment, the first one just practically gives you everything. So type in make directory bin. So I'm in my home directory, and I'm going to type make mkdir bin. And lo and behold, I have the bin directory. I also have test. I'm going to leave it alone. I don't really worry about it. Now I have bin. Hopefully you guys are this far. Change the directory to bin. Shall we go cd bin? Here we are. Bin's empty. Nothing's inside a bin. Did we get this far? Or am I going too fast? Why are you shaking your head? Okay, hold on a second. Alright, so once you're in your student folder and you've created the directory bin, we're now on number 2. That was number 1. So number 2, in your bin subdirectory, we're going to create the following file and we're going to name it commands. Okay? We're going to use Emacs or VI or any text editor. Well, Nano's a text editor. That's the one I'm going to use. So this is the information we're going to put into it. So I'm just going to go nano space, and it's going to be called commands. So I'm going to press return. And here's the weird part. I'm going to put the hash sign. The hash sign says that this is a comment. So I'm going to say a simple shell script. And inside my simple shell script, I'm going to have 3 commands. Cal, date, and who. And looks like it's pretty good. I know some of you are slower typers, so I'll slow down a little bit. And I'm going to save it. So I'm going to go, I got 2 ways. I can go Control-O, excuse me, Control-O, and call it commands. Or I can go Control-X, and then it'll ask me if I want to save it. So I can save it and then exit it, or I can exit and then save it. Either way, I'm going to verify that it's there, and it is there. So I see commands. And then I say, well, let's run commands. So it says save the file, leave the editor, and try to run commands. Well, how do we run the command? We type in commands. Commands. And it says commands not found. And we go, okay, let's go /commands. And we say permission denied. You want me to try cat next? That's the wrong answer. No, it's okay. And we have to change permissions. So then we look at this as a learning exercise. We look at this. It's not supposed to run. We look at this. Do you see any X's anywhere in here? X's means to execute. The letter X. I don't see any X's. I see a read, a write, a read, and that's about it.
I got 0.
You got 0? What do you mean? Yours says 0?
Still 0.
Let me see. Actually, I'm curious. Okay. So it's not supposed to run. So this is what happens. I'm not expecting an answer to that question. You could just, if you wanted to turn this in, you could go number 2. It doesn't run. It's not going to run. So number 3, it says make the script executable. So we got to put an X in there. So if we use this command, we're going to type this in here. If we're going to type in chmod, and then we're going to put in what we're going to change it to. So remember before I did 777, so I said change mod. I'm going to change mod right now to 77. You don't have to do this, but I'm going to do it just to show you something. I use the number 777. Tomorrow I'm going to go through, I'm not going to go through it today, but tomorrow I'll go through what these numbers mean. There's 3 sections of it for the numbers, and I'm going to put in here commands, which is the name of the file. So this is the command. This is the switch for the command, but there's no minus sign. It's just a parameter you're going to provide to it. Change the mode, the mode. And this is going to give it everything commands, and then press return. And now if I run an ls-l on here, I see I got all these. I got an X here, I got an X here, and I got an X here. I got 3 X's. Do I really need 3 X's? Probably not. But now it's green, which means if I run it now, if I type in commands, the thing says there's no commands. If I put it, now I have commands. What did commands do? How weird. What did I put at the end of commands? Now I have to see what I put in there, but now I got a list of all these students in here too. Let me run commands again. Oh, okay, I must have put something in the end that listed out everything. So, what did I put at the end in here? Who? I did who. Who? Well, I put who in here. It means who's on the system. So you guys are on the system. I guess we could do attendance this way. This is who's on the system. Which is what this is doing, is if I type in who, I get who's connected. See, last time I typed in who, only about 3 people or 4 people were connected. Everybody's connected now. So, as soon as I say, oh, we're doing the first assignment, everyone's connected. All right, so what I'm trying to demonstrate to you is I gave you too much. I got read, write, execute, read, write, execute, read, write, execute for all 3. User, group, and other. Kind of overkill. If I use what's in here, this is a different way of doing it. Let me show you something actually. I'm going to copy this. I'm going to paste it in this little window. Now I'm going user and group. U stands for user, G stands for group. Add plus X. Well, that's not going to do very much. In fact, if I look at it again, I'm going to go, oops, ls minus L. Well, you didn't change anything. I still got read, write, execute, read, write, execute, read, write, execute. But let's do something else. Let's do it this way. If I change the mod to 0, 0, 0, and then I go like this, and I go, all right, now I got this under control. I've wiped out everything. Now I'm going to run that other one. All I'm doing with this one is I'm changing the user group, and I'm adding execute. So if I do this, and I go like this, now I have X and X to user and group, but not other. Huh?
What happens to read and
It's still gone. I'd have to write, read, write. So I'd have to do this. I'd have to do, if I wanted to. In fact, this isn't going to work, because, well, actually it would. I can execute it. So let me just make sure. Yeah, I can still execute it. Executing, but I can't open it. So watch this. So let me just make sure this is correct. I have execute for user, execute for group in this command here. Just trying to make sure everybody's on the same page. So I added X to user. U stands for user, G stands for group. But I could put an O in there if I wanted to and put it for other, but it doesn't really matter. I can't read or write. So let's go nano. Commands. Am I the user? Let's write it out. Let's put something else in here. What can we do in here? ls minus L. There we go. It's another command we know. Control X. Save it. Yes. Commands. Yes. And I'm like, what happened? I'm the admin. That's what happened. I have better privileges. Anyway, long story short, bad example. I'm the admin. So other users should not be able to read it or write it Just the same way as you can't access something that you can read, you can't execute. So if you look at the files that are in here for you guys, you have, wow, we have different IP addresses too. Interesting. Who's user 9? Who's number 9? How are you connected? You have your own service? Are you on the Wi-Fi?
Putty.
Huh? You're using Putty? You're coming in on a different IP. Everybody else is on the same domain. You're on a different
I
one.
think it's my office computer.
Your office computer has hard set. You're not using DHCP. You're using static IP addressing. And that's okay. Don't coach. It's okay. I just noticed you're coming in on a different server. And you might be careful. Someone on that network is watching what you're doing probably. If you're on a work computer. Because that tells me that you're running under a private network domain. You're not actually connected. You're going through a different server than everybody else in this room is. You're connected to a VPN.
Yeah, I connected to it.
Yeah, that's why. You got a different IP address going on here. We're all connected from ITU, which is this is ITU. So you all connected to the ITU Wi-Fi. Except for this one guy. It's okay. But I can tell where you're coming from, which is interesting. So if you're running an application, you can say, where are all these students? They're at ITU right now. And then I can go later on, I can go, well, this guy's from another state, or this guy's from another country, or this guy's from a different VPN. And I can kind of monitor what's going on. And then I can knock you off if I wanted to. Using who I can say, well, let's see, this is student 9. I can lock your account or log you out, get rid of you if I wanted to. I'm not going to. Anyway, long story short, my system failed because I'm the root. I got privileges to everything. I can do anything I want, which means the privileges don't really matter. However, if you wanted to fix this, you just add other stuff. So if I go back to this command, and then I say, let's add R and let's add W and X. So I typed in chmod user and group plus RW and X, and then I go -L. Now user and group is now read, write, and execute, but other is still empty, which means it's not open to the public. You actually have to be on the server. So the user is you, how you're logged in. The group is any profile that you might belong to as a group. You also have a group assignment. You're all in the same group, which means if you do group, everybody in your group now can read and write your file. Not necessarily a good thing, maybe not. And then the other is anybody not logged into the network who's going through an HTTP protocol, let's say, for example, through a website. Those guys are the others. Everybody outside of the network who's logged into the network, who's got to the network somehow but is not logged into the network. When you're in Google and you're going to a website, you're not logging into the server. You're other. So that's the other. So other is important for websites, for public HTML directories and folders. Things that are open to the general public where the people are not logging onto the server, those guys are the others. So just keep that in mind. We'll go through a lot more of these commands as we go through the course. Now you run it and it works. So make sure the bash shell is always executed when you run this script. So we're going to change the script now. And we're going to put this line. So go back to the text editor and add this line to the top of your shell. So we're going to go nano commands. And then at the top of the shell, let's put it underneath. Yeah, let's just put it at the top. So, or we could just, you know what, I'm going to change the comment line. And I don't think this is going to work because I'm getting lazy now. I can't paste it. Oh, it does paste. Look at that, it does paste. Look at that. I'm going to change that line so instead of it just, it's still a comment, but instead of saying it's a shell script, I'm going to put in here the comment line and I'm going to say use this asterisk is talking to the kernel and saying use shell, so let a new shell. So it's the same similar syntax used to say Perl, Python, stuff like that. PHP is a little different. A little arrow and a dollar question mark. And it says PHP next to it. It says use the interpreter. So I've added this little piece in number 6. So in the continuation, when you call a shell script with arguments, so you can access them inside the script using variables. So now when we run our script, so we're going to change it so it runs with bash shell. So that was the first step. So we added that to the top of the file. Now we're going to put in some positional parameters. So when we type the name of the file, you know how I've been doing ls minus l, and I've been giving it parameters? We're going to give some parameters to our script by putting in some positional parameters. So when you call this shell script with arguments, you can access them inside of the script with special variables. For example, $1, $2, $asterisk refers to all of the arguments, and the variable $0 refers to the name of the calling argument of the program. We're going to do that in number 7. So we're going to create a script called echoes arguments. So we're done with this script, so we can save this script. I can take out ls minus l on the bottom of here. I'll take this out. If I want to take it out, I can use the delete. So there's one in here, Control K, excuse me, to cut the text. So Control K got rid of that line for me. So there's some, you might want to experiment. Control T, spell checks, spell check failed, error, bad file descriptor. Okay, whatever. I don't have a spell checker installed. So you can spell check, you can run some of the other commands on the bottom here. I'm just going to save it now. So I'm going to save the file name as commands. Yep. And I'm going to exit out. I'm going to still make sure my commands works okay. And it does. So now I'm going to make a new script. So the way I'm going to know that you did this is I'm going to go and I'm going to look in my FTP folder. I'm going to see a bin directory. I'm going to see commands in there. So then the rest of it you just give me in the Word file. So you upload into the, you still have to upload something to the EMS, but you still have to answer number 1. Number 1's got the shell comparisons. That's pretty easy. All right, so number 7. We're going to create a script. It's going to be called echoes.args. I'm doing this because I want to show you, just like in number 1 we just did commands, we don't need to have a file extension. So forget everything about these file extensions you get in Windows. You don't need to have a .text on the end of that or a .exe, nothing like that. You notice we didn't do that. So let's call it echo.arg. So nano echo.args. Is it ARGS? ARGS. Now I just realized I can cut and paste. So now my typing got a lot easier. So I'm going to take and copy this here. Copy. Paste. Look at that. I'm going to fix it up a little bit though. So this one's going to run the bash script. And this one illustrates the use of the positional parameters. So what do we got here? We're going to echo. We saw echo a couple of times already. Echo repeats stuff to the screen. And the echo $sign repeats the value. So remember we did echo and we created an environment variable, and then I took and I put a $sign in front of that environment variable. I can't remember what I called it. Mule something. I misspelled my something. And I got the value of 10, my variable or mule variable, whatever I called it. Same thing here, except for the commands that are coming in are in a positional array. So if you're familiar with C programming, this is the command line arguments. Automatically come in. Oh, I just copied it over here and pasted it over here. No, I did it this way. Copy, paste, but I'm on a Mac, and the Mac is a superior operating system. You can't do this on Windows. I'm just kidding. You asked. I know. You gotta take what I say about Macs and PCs with a grain of salt. Now, I'm actually kind of cleaning this up a little bit. I noticed some spaces. The spaces don't really matter, actually. Spaces don't matter. However, when you echo it, actually spaces do matter when you echo. It'll put an extra space in there. So I put the space, I got rid of the spaces because if I do number 1, 5 spaces, number 2, 1 space, number 3, they won't be lined up right. So that matters. The spaces between echo and the first command doesn't matter. I could put echo, it's just like C, actually. I could do this. No, the line return is going to matter. I was going to say if I put it at the end of the line, if I put it on the next line, it's going to matter.
Yeah.
But it's all on the same line. Doesn't matter. The spaces don't matter. I could put extra spaces in there. It just reads it till the end of the line, takes the line in. So this one should be echoing out 0, 1, 2, 3, 4, 5. And you're wondering, where are these coming from? And then I was going back to the command line arguments and C. You remember main, and there's that argument array. All I have to do is capture. Well, you get it automatically in here. So if I say echo.args and I run the command and I give it 5 arguments or 6 arguments, it'll take it in and it'll print it out. The rest of them is going to be blank. So it's automatically indexed 0, 1, 2, 3, 4, 5. So if I come over here and if I make the script executable, and then I'm going to try it out and see what happens. So I'm going to go ahead and save it. So I'm going to say a file name to write is echoes. Okay, that sounds pretty good. Look at that. All of a sudden, I got a green, I got color coding going on here. It's like, ooh, we recognize it. It's something. So then I'm going to go X. And then I'm going to change. So I'm going to do a cheat sheet here. I'm going to use my arrow keys. I'm going to go back. And I don't really need to actually do this one. I'm just going to do this one. And I'm going to change the name to echo. Echo.arg. Did you notice actually I had some extra spaces in here? Actually, I had a couple spaces in here like that. Yeah. It doesn't matter. It just reads the whole line. So let's see what. Oh, no such. Let's say echo args. Oh, probably because I misspelled it. Yeah, thank you. As soon as I make a mistake, everybody in the world knows. All right. It's green. So I'm going to go echo args. Let's see. 1, 2, 3, 4, 5. Command not found. All right. So I'm going to go dot /. And then I get 1, 2, 3, 4, 5. But what did it really echo? I did echo arguments. Wait, did this work or not? Was I printing out? I have to look at the script now. Echo 0. Oh, 0 is the file name. All right, I'm like, what? Okay, hold on. Let me modify this just for my peace and my insanity here, or my sanity. Let's see. Let's get rid of 0. Once you make it executable, it's always executable. Just because I changed it, I don't have to, no one's asked this yet, but just in case I changed it, I saved it again, and I don't have to change the command, I don't have to do a change mod again. So you see what I did? I took out the 0. The 0 is the file name. Before when I ran it, it was giving me 0, argument 0. Argument 0 is the name of the file. If you see it, actually see it up here. I'm like, wait a minute now. I don't like the way that looks. It looks confusing to me. Students aren't going to be able to tell that it's the command line arguments that are being printed out. So I took out argument 0. So I did, now it says 1. Let's just take out 1. And, oh, actually I don't have to take out 1. You're going to understand, right? If I put argument 0 back, argument 0 is the name of the file that I'm running. 1 is the first argument, 2 is the second argument, 3 is the third argument, all the way up to 9 arguments. So if I run the sucker with, I only put 5 of them in, I got 5 of them out, so I can go 1, 2, 3, 4, 5, 6, 7, 8, 9. I know there's only 9, 10. I'm going to get 9. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Yep.
Yeah. So what I'm doing is just regurgitating. I'm running the command with the arguments. I got rid of the 0 argument, which is the name of the file. You can leave yours in, it doesn't really matter. If yours has 0, and I'm going to know that you understood the concept, that you actually performed this exercise. And then you see it got 1, 2, 3, 4, 5, 6, 7, 8, 9. Normally we wouldn't just be echoing them, we would use them. Like, for example, ls minus l. Takes minus l. Inside the ls command, it goes, what? The user wants to use the minus l. Okay, what is that? You know, giving them the long stuff. So print it out this way, and it changes the execution. So what we're going to do in the next couple more scripts is we're going to take and use the arguments to do something with it. I don't know if we're going to do it in this exercise. We actually will. Change the script so it looks like this. Echo, what is your name? Read the name. So tomorrow when we start, because I'm going to end right now because this is a really good stopping point actually. Tomorrow we're going to start with number 9. And someone's got to remember I stopped here. So I'm going to start with 9. We're going to finish this one. We have a couple more left here. A few more left here. And then we'll start in with exercise number 2. And then I'm going to let you do some of it on your own while I supervise because we don't want to do it. But in the beginning, we have to sort of just do stuff together. And then I want you to struggle a little bit and experiment a little bit on your own as we go through number 2, number 3. Like, I'm not going to do number 1 for you. You have to go home and do that on your own. So as we go through, we'll do parts of the assignments in class, and you'll do parts on your own, which is how the class is going to run.
So these things we need to upload.
At the end, when we get all done with this, and probably by the end of the weekend, you're going to have to turn in this one here. So you'll have to upload something. Each one of them requires you to upload something. In this particular one, it's just the question number 1. The rest of it, it's all done on Unix. You do it on your Unix account. Later on, I can look at your directory. I'm looking for a bin directory. And inside a bin directory, there's going to be a commands file. And then there's going to be this echoes file. So right now, if I take a look, I have these 2. I'm looking for them. It means you did it. If you did it, you get an A. If you didn't do it, you don't get an A. I mean, it's like an all or nothing. So I'm not going to critique the file. So don't worry about it. If you want to be creative, you can add some more stuff to your commands file. Or you can do some different stuff. Like I changed echoes to take out the file name because I didn't like the 0 argument. You could do that too if you want to. Do we have questions? No? Okay, good. So I have a couple extra computers if you people are having problems with your computers. Did yours work out okay today? Okay, good. So you can leave it there. I'll pick it up later. Let me stop the video. We are done for today.